Today, we are finally pulling back the curtain on one of the most anticipated 3D printers of the year, the Sovol M1D IDEX Toolchanger. A first video like this can only give a broad overview of this unreleased Infinity Gauntlet. We'll see how it achieves 0-second material swaps, test how it handles different brands of filament, check out how to fully utilize its surprisingly massive build area, and peek under the covers to figure out why its motion system isn't the otherwise popular CoreXY architecture. Plus, as always, I managed to break a few things during unboxing, so you don't have to. This is Gergo, and welcome to Gergo Print 3D, your go-to YouTube channel for everything Sovol, where we also check out other 3D printers, lasers, CNC machines, and fun DIY projects. Just like all our videos, this first look comes with curated translation-ready subtitles, chapter markers, and audio tracks in multiple languages to give everyone the smoothest viewing experience. Before we start unboxing this giant, a quick heads up, Sovol sent us this pre-production M1D unit for early testing. Because it is a pre-release machine, some non-critical brackets are still 3D printed, and the software is receiving over-the-air updates almost weekly. But even in this early state, it has already fundamentally changed how we look at multi-material printing. Our M1D arrived in a 40 kilo or 90 pound flat pack box. If you can lift this by yourself, kudos to you. But don't let the weight scare you. This printer comes nearly 100% pre-assembled. It's definitely not a Voron build. It only takes a few major components as we attach the 4 Z columns to the base, connect the corners of the drop bed to the 4 columns, secure the top gantry using a few screws, add the AFS feeder in the back, and plug the swap-in tools to their connectors. Sovol packed this unit extremely well, but in true Gergo Print 3D fashion, I still managed to make a mistake. Yes, I know. While lifting the heavy gantry out of the tight foam, I snapped the plastic mounting bracket of the Y-limit sensor board right in half, which also tore the Wi-Fi antenna attached to it. 3 components destroyed with a single move. Truly my level best. Before we put those broken modules back together, a quick shout out to our sponsor PCBWay. Whether we are building custom 3D printer controller boards, prototyping replacement sensor breakout boards like the one I just snapped, or looking for high precision 3D printing, sheet metal fabrication, and CNC machining, PCBWay is the ultimate one-stop shop. You simply upload your Gerber or CAD files, get an instant quote, and receive professional industrial-grade parts delivered straight to your door. Check out the link in the description below to bring your next electronics or mechanical project to life with PCBWay. Fortunately, Sovol clearly knew who they were dealing with because they actually included spares for all 3 damaged parts right in the accessories box. We make mistakes, so you don't have to. The bracket is admittedly a nightmare to secure without taking the top assembly apart. And imagine my horror when I realized the optical sensor PCB board itself was also damaged after my first reassembly. Once assembled though, we quickly realized just how impressive this machine looks. And hint, it isn't actually that big relative to its print volume. The core frame measures 56.5 by 56.5 centimeters, but once you add the backside mounted AFS unit, the rear batten tubes, the left side spool holder, you'll need about 70 by 63 centimeters of actual bench space. Of course, you will also need room for the 6-spool filament rack or your favorite filament dryer on the right side. If you want to relocate the AFS unit elsewhere, keep in mind you'll need to extend its 6-pin microfit cable and adjust the length of the 6 pre-cut PTFE tubes. Vertically, because the filament guide loops extend significantly above the top, you will want at least 100 centimeters or about 40 inches of clearance above your desk. Even the entry-level Essential variant is completely enclosure ready out of the box. The side extrusions feature pre-drilled mounting holes. The top frame includes rubber sealing strips for the top hat, and tucked away in the back are 3 unused electrical connectors wired for chamber circulation fans and an active chamber heater. If you decide to pick up an M1D, getting the advanced variant gets you a nice bundle discount on those official enclosure components. Now let's talk about the mechanics. Even Sovol refers to the gantry as an AB axis assembly, which led me to assume this was a CoreXY printer. But being an IDEX, it cannot be. The M1D is a true Cartesian IDEX system with dedicated X and Y motors, where the right carriage functions as a full-fledged tool changer. The motion system is built like a tank, using 3 heavy-duty linear rails driven by massive 48mm NEMA 17 stepper motors and wide 9mm 1.5 GT belts to minimize VFAs with easily accessible tensioners. Down below, the insulated AC heated drop bed is supported by 4 independent lead screws running a full quadrantic calibration routine before every print to eliminate any twist or tilt. Aligning 7 independent hot ends is the key to flawless prints. The automated process is impressive, though we will need to run the 15-minute calibration routine out of the box and whenever we swap nozzles. A physical bed button in the back measures the exact vertical contact height of every hot end, while an upward-facing camera scans the nozzles to build a horizontal offset coordinate table. We also get a front-facing chamber camera for AI monitoring and time lapses, but looking closely at both tool head carriages, there are dedicated nozzle inspection cameras mounted right behind the hot ends. Mine had protective shipping peels over the lenses, not mentioned in the manual, so check for those before your first calibration. Now let's be honest, looking at these 6+1 tools on the M1D, who hasn't pictured Thanos with the 6 infinity stones on one hand and a heavy IDEX fist on the other? Sovol basically built the infinity gauntlet of 3D printing here. With a single snap of its gantry, we get 7 colors with virtually 0 waste. If wielding this level of cosmic multicolor power gets your vote, snap that thumbs up button, make it inevitable by subscribing, and please drop us some hypes down below. Perfectly balanced, as all things should be. The printer runs standard Klipper with a fully accessible mainsail web interface, full SSH root access using the lowercase word Sovol, both for user and pass, and a crisp, snappy 5-inch touchscreen. It is a joy to use. We get 32 gigabytes of local storage, 1 gigabyte of RAM, instant Wi-Fi connectivity at 2.4 and 5 gigahertz, separate controls for both part cooling fans, bed temperature control up to 100°C, and OTA firmware update support right on the device screen. Filament management is handled mostly through the touch screen. When unloading the left independent IDEX tool head, the printer heats the standard MKA nozzle, adjusts the motorized nozzle height, that's the little spinning wheel on its top, tip forms and retracts. However, there is no auxiliary feeder motor on this left side, so we have to manually pull and wind the spool of green tag bears PLA Plus by hand. There is also no cutter in the tool head. This is how the tip looks. When we load that same tag bear green PLA Plus back in, the M1D checks the runout sensor at the entry of the tool head and prompts us to hand feed if it's not present. I tested feeding from a dryer box this time. but the extra drag causes a slight under extrusion. I'm planning to install a BQ Panda feeder here, which will also save us from having to manually push the filament all the way to the extruder. The tool changer on the right works a bit differently. Because the main extruder motor is part of the tool head carriage, the active tool is automatically parked before picking up the selected one. Nozzle heat up and tip forming happens the same way as on the left, but here the AFS handles the motorized pulling. Winding the unloaded filamentary white PLA blaster back onto the spool has to be done by hand still. Loading is much easier. We simply introduce the leading end of Filamentary's yellow PLA into the AFS. It pulls in about 10 centimeters. Then we tap load on the screen and the AFS drives the filament all the way up and down the batten tube to the tool head, where the carriage extruder grips it and purges into the purge bin. I had noticeably better success feeding from the Sovol SH03 dryer on the right side, though the stock open filament rack can hold all 6 spools and it is fantastically friction free. I think we will actually stick with this stock rack for now and eventually move the M1D into our humidity controlled dry room. Make sure to check out our popular video about that dry room setup. Time for a few test prints. I printed a plate full of these 2-color soccer balls without material change, just using the 2 tool heads. We were getting instantaneous 0-second material swaps when switching between the main left IDEX head and the right tool changing carriage. While one head is actively printing, the other is already fully preheated and parked right at the edge of the print bed. They take over from each other instantaneously. With that success behind us, the literal second model to print was this Monkey D. Luffy model you've seen us print on our single head Creality printers using the CFS last year. I loaded all the necessary colors: white, black and yellow from Filamentary, red, blue and orange from Tech Bears, and the most prominent skin color first from Anycubic, then because of a persistent clog with that PLA, from a less ideal looking G-Tech PLA in the left tool head. Switching between the skin color and the other colors is instantaneous. Tool changing on the right carriage is only slightly slower, swapping between its 6 parked tools in about 5 seconds, nearly 20 times faster than any AMS or CFS or ACE systems. The M1D achieves this through smart nozzle preheating. While tool 1 is finishing its layer, parked tool 2 is already heating up in the background. All tools are wired in their parking locations. When parked, nozzles cool down to a standby temperature and rest directly against spring-loaded rubber plugs to seal the tips. Because of this mechanical seal and the dedicated individual tool heads, purging only happens the very first time a specific tool is introduced during a print. After that initial purge into the rear purge bin, the tool head drops straight back into action with 0 extra waste, requiring only a small prime tower. On a complex multicolor model that used to take over 20 hours and generate 350 grams of plastic purge poop on a CFS system, the M1D finished in 1/5 of the time with only a tiny fraction of the waste. My only real gripe with this purge bin is that it sits directly behind the moving print bed. I'm already sketching out ideas to redesign this bin so it can be emptied easily from the back. While the volume of waste is incredibly small, the purged filament turns out a bit stringier than the solid poops generated by other printers. We'll see what 3D Print Demon Klipper Essentials can do with palette forming. And while we are talking about printing, we need to clear up the confusion around the true build volume. The sticker shows 300 by 300 by 350 millimeters. The height is a given, but the usable width can actually be more or less, depending on how we utilize the IDEX system. The physical magnetic bed plate itself is massive, measuring 340 millimeters deep by 365 millimeters wide, completely dwarfing the plate of a real 300 by 300 printer, our Sovol SVO6 Plus, for example. In practice, the stock double-sided PI plate delivered great first layer adhesion. My bed plate turned out remarkably flat, with the mass showing a variance of just 0.236 millimeters at 50C, and even at the maximum 100C, the range stayed below 0.25 millimeters. Standard SVO8 and Bamboo H series plates fit quite nicely, though their rear notches won't align perfectly with the M1D's excellent backstops. These are the best backstops I've had on a printer. So how do the parked IDEX tool heads affect our available print size? If we print a single material model using just the left tool head, or a maximum 6-color print using only the right, we get the full advertised 300 by 300 millimeter area. It's similar, if not slightly bigger than other tool changers on the market, but still the same boring stuff. Then we unlock the superpower of the IDEX. When we run continuous 0-second multi-material swaps on a single object using both heads simultaneously, giving us 7 materials in total, the only little price we pay is the shared overlapping width shrinking slightly to 240 millimeters, but only in this mode. And if we switch the printer to IDEX copy or mirror mode, the full physical width of 356 millimeters opens up. Both tool heads move in tandem across this entire width, allowing us to print batches of 2 or more identical or mirrored parts at the exact same time, effectively doubling our production output speed while maximizing our total printable volume. The Sovol M1D is a fascinating and very capable machine. The one word that kept coming to my mind throughout testing is versatile. Combining a true IDEX layout with a 6-tool changer gives us unprecedented flexibility. Whether we want to print high-speed multicolor models without wasting filament, combine rigid structures with flexible TPU inlays or covers, discover full-spectrum CMYKW printing, batch print parts, or use dedicated non-fusing support materials without contaminating our primary hot end, this machine handles all these with ease. It isn't completely without its quirks though. One, there is still no quick swap nozzles here, though the standard MK8 nozzles used are inexpensive and widely available in various sizes and materials. The rear purge bin layout could definitely be improved. The filament spools remain open to ambient air, though the AFS is easily strong enough to pull filament straight out of a sealed dryer. We found the stock software interface to be somewhat basic. What it does reliably, but it is currently missing convenience features like filament mapping and direct slicer synchronization. Hopefully these will be added later, maybe even before release. Idle noise isn't as loud as on our earlier Sovol test machines. We've had this printer for 3 weeks now, and I still haven't replaced the MCU fans, which is a first for a Sovol machine, but it could still be quieter. Print noise, on the other hand, is louder than normal, but not because of the motors. Our pre-release software runs the part cooling fans in both tool heads even when one of them is parked, which makes a little bit of sense for controlling oozing, but they could easily halve the printing noise by simply stopping the fans in unused tool heads. And finally, we will be releasing our standard measurement video soon, featuring exact decibel, noise levels, heat-up speeds, gantry resonance, power consumption figures, and the like for this pre-production unit. Out of the many brands we tested, Anycubic's Pastel PLA consistently clogged inside the left tool head, so I'm now quite experienced at disassembling the extruder by removing just 4 screws. Unclogging the tool changer side would even be easier, but we never really had to. The stock slicer presets in Sovol Slicer, a fork of Orca, worked brilliantly with Sovol's own filaments, as well as Filament 3, JU 3D, and Tag Bears materials. I eventually got that problematic pastel filament to print smoothly too, simply by reducing the retraction distance in the slicer. We will be showing many more test prints and sharing our ongoing experience with various technical filaments and TPU that you asked for and PETG in our upcoming follow-up video. TPU should load easily from the AFS. Even with enclosure, the 300C max nozzle and 100 Celsius bed limits this printer to ABS or ASA at best, but I'm not printing those without an enclosure. We've had the privilege of early testing almost every recent Sovol printer. The M1D isn't perfect, but it is closer to perfection than any of those earlier machines were before their release. Considering how rapidly Sovol is refining the firmware and hardware, this printer is shaping up to be an absolute blast for serious makers and small production farms alike. If you're thinking about grabbing your own Sovol M1D or picking up any Sovol gear, please check out our affiliate Kickstarter and VIP links in the description below. Using those links costs nothing extra for you, and it directly supports our channel, so Levi and I can keep producing the printer upgrades, repairs, and tutorial videos we are known for. A special thank you to Filament 3, JU 3D, and Tag Bears for providing the filaments for our tests. And a massive shout out to our most dedicated supporters on Ko-fi.com. Slicks, Juma Pili, TechGeek10, Wing57, and Jan Parel leading our top supporters board. You are welcome to join them for direct access, exclusive behind the scenes content, and early project updates. Drop any specific questions you have about the M1D in the comments down below, and we will gladly test them out for our follow-up videos. We already have a long list of requests from the videos in the shorts feed. You can watch all of those shorts in our dedicated playlist, or check out our most popular dry room setup video right here. Until next time, grab some filament and go print 3D. Thank you for watching another Gergo Print 3D video all the way through. Reality can be whatever we want.